Hello everyone, welcome back to my channel. So in this today's lecture we'll understand what is chopper, types of chopper, chopper. After that elaborately we'll understand what is step down chopper with R load, and from this we'll find out what is the average voltage, expression for average voltage, then RMS voltage, ripple factor, and form factor. Chopper basically a static device. It is a static device which is used to obtain a variable DC voltage from a constant DC voltage source. So this is the definition of chopper. A chopper also known as DC to DC converter. This chopper is also known as DC to DC converter, and the thyristor converters offers greater efficiency. So here to design a DC to DC converter we use thyristors. So efficiency is high, then smaller size and smoother control. Smaller size, smoother control. So these are the advantages of DC to DC converter or chopper. Choppers are classified into two types of chopper. Into two types. First one is step down chopper, then step up chopper. So simply you can say, in case of a step down chopper, output voltage will be lower or less from input voltage. In case of a step up chopper, output is higher than input voltage. So this is the these are two types of like step down and step up chopper. So now elaborately we will understand step down chopper for R load and RL load. Okay, this is the circuit diagram. This is the figure of step down chopper. So here one voltage source, then there is one chopper. So this is the thyristor, and one resistive load. This is load. A load is resistance is connected as a load. So when the thyristor in the circuit act as a switch, here this is thyristor. This thyristor is act as a switch. So when thyristor is on, supply voltage appears across the load, and the supply voltage appears across the load. And when thyristor is off, the voltage across the load is 0. So this when switch is on, that how these voltages appears across the load, and what will be the graphical representation, that we will see in the waveform. So here it is showing the two waveform, one for the voltage like input voltage. So here the two graph represent the output voltage and output current. this upper, this one is output voltage and output current. So here we can see, when here we are getting the output, so means here T is on, this thyristor is on, this is the on time of the thyristor, and this is the off time. T, when T thyristor is off, this is the off time, and this is the total time. So this is the on time. When thyristor is off, we are getting some voltage across the load. So this, when thyristor is on, we are getting some voltage across the load. Now when thyristor is off, at that time that voltage is 0. Again, when thyristor is on, we are getting some voltage across the load, and again it will be 0 when thyristor will be off. And if we see the current also, so that is also similar, that waveform is also similar as voltage, when there is a, when thyristor is on, at that time we will get that current across the load. When thyristor is off, that current will be 0 again. So when thyristor will be on, we will get the voltage across the load, and when the thyristor will be off, across the voltage load, across the load voltage will be 0. So both the waveform is moreover similar, as it is a resistive load. So both the voltage and current are in phase. Voltage and current are in phase. So that's why we have achieved both the waveforms, similar types of waveform. Here this line, this yellow line, this is shows VDC, that is the average voltage. This is the average output voltage or average load voltage, and this is IDC. So this is the average output current. And T on, so this is the turn on time of the thyristor, and this is the turn off time of the switch or thyristor, and T is the T on plus T off, and F is equal to 1 by T. So this frequency is the chopper frequency of chopper switching or chopping frequency. This we can say chopping frequency. Okay, now we'll understand what will be the, we'll find out what will be the average output voltage and average output current for when resistive load is connected for this step down chopper. Average output voltage we can write from the waveform, we can write when T is on, when that switch is on, so at that time we got the voltage. So we can write VDC is equal to V into T on by T on plus T off. This is equation 1. Again, from this what we can write, V into T on by T. So that is V into alpha. As we know, alpha is equal to T on by T. So this is, alpha is the duty cycle. So this is the duty cycle. Now average value of current, we can find out IDC is equal to V DC by R, that V by R. So that is V by R into T on by T. So that is V by R into alpha. This is equation number 2.